This class we work out three problems. First problem is a three-phase system supplies 1500 watts to a star connector load at a 0.8 power factor lagging. The question is determine the value of line and phase current and per phase impedance and also draw the phasor diagram. So this is the diagram. Line voltage is 400, per phase voltage is 400 by root 3, that is equal to 231. So per phase power is given 500 watts, voltage is given 231, theta is equal to cos inverse of 0.8, that is equal to 36.9 lagging. I can calculate IP. So per phase power is equal to 231 into IP into cos theta is equal to 0.8. So 500 is equal to 231 into IP into 0.8, IP is equal to 2.71 amps, that is the current. Next I have to calculate the impedance. In three phase, line current is equal to phase current, line voltage is equal to root 3 times phase voltage. Impedance is equal to per phase voltage by per phase current, 231 by 2.71 angle minus 36.9. That is equal to 85.244 angle 36.9 degrees. That is the impedance. Now I can calculate resistance. R is equal to Z into cos theta, X is equal to Z into sin theta. R is equal to 68.192 ohms, X is equal to 51.114 ohms. So this is the phasor diagram. Blue is the per phase voltage. This is VR is equal to 231, VY is equal to 231, VB is equal to 231. It is a balanced system. VRY is equal to 400, VYB is equal to 400, VBR is equal to 400. So IR is equal to 2.71, IB is equal to 2.71, IY is equal to 2.71. This angle is 36.9 degrees, that is lagging. Second problem, the unbalanced star connector load is fed from 3-phase 4-wire 400 volt 50 Hz supply. Line to line voltage is 400. Determine the current in each of the 4 wires. What is the current in the R phase, Y phase, B phase and the neutral? That is the question. Here ZR is equal to 115.5 ohms resistive load. This is 80 ohm inductive load. This is 40 minus J30 ohms. That is ZB. So line voltage is 400, per phase voltage is 231. So VRN is equal to 231 angle 0 degrees. VYN is equal to 231 angle minus 120 degrees. VBN is equal to 231 angle 120 degrees. Now I can easily calculate IR, IY, IB. I know the per phase impedances. IR is equal to VRN by ZR, that is equal to 2 angle 0 degrees in amps. IY is equal to VYN by ZY, that is equal to 2.89 angle minus 210 degrees in amps. IB is equal to VBN by ZB, that is equal to 4.62 angle 156.87 degrees in amps. Neutral current IN is equal to IR plus IY plus IB. Neutral current is 5.762 angle 145.55 degrees in amps. So this is the phasor diagram. This is VRN, VYN, VBN. This is IR, this is IY, this is IB. Here this is a resist load in phase with the voltage. Here the current is lagging in the Y phase. The current is lagging. Here in capacity load the current is leading. This way you have to draw the phasor diagram. Third problem, 3-phase 4-wire 50 Hz 400 volt supply. Phase sequence is RYB. This is a 3-phase 4-wire system. A non-inductive load in the R phase takes 70 amps, Y phase takes 80 amps, B phase takes 30 amps. The first question is calculate the neutral current. Second question is, if a 3-phase induction motor is started, the induction motor taking 200 amps from the lines at a power factor of 0.6. So this is an unbalanced load, this is a balanced load, supply is balanced, supply neutral is N, load neutral is S, all are linked neutral. This is a 3-phase 4-way system. what should be the current in the neutral, and also find the power supply to the lamp and the motor. Okay, this is a unbalanced load, this is a balanced load. When unbalanced load comes, then only the neutral current will come. If the load is balanced, there is no neutral current. Okay, we know it very well. This is IR is equal to 70, IY is equal to 80, IB is equal to 30. How to calculate neutral current? First we have to calculate the x-axis component. That is 80 into cos 30 minus 30 into cos 30. 80 into cos 30 minus 30 into cos 30, that is equal to 43.30 amps. Y-axis component 70 minus 80 into sin 30 minus 30 into sin 30, that is equal to 15 amps. Neutral current IN is equal to root of Ix square plus Iy square, that is equal to 45.82 amps. So that is the neutral current. The motor is balanced. There is no, the motor, if you start a motor, neutral current will not vary. When a 3-phase motor is started, it takes 200 amps. In all the phases to take 200 amps. What is the new IR, IY, IB value? The power factor is 0.6, theta is equal to 53.13 degrees. Okay, so this is the phasor diagram. You have to calculate IR. IR is equal to root of 70 square plus 200 square plus 2 into 70 into 200 into cos 30. Cos 30 is equal to cos theta. Cos theta is equal to 0.6. So IR is equal to 48.39 amps. Similarly, IY is equal to root of 80 square plus 200 square plus 2 into 80 into 200 into cos theta. Cos theta is 0.6. That is equal to 256.12 amps. IB is equal to similarly 30 square plus 200 square plus 2 into 30 into 200 into 0.6. That is equal to 219.32 amps. That is the new IR, IY, IB after switching the 3-phase induction motor. Last we have to calculate the power supplied to the lamps. Power supplied to the lamps, P is equal to V into, that is 231 into 70 plus 80 plus 30, that is equal to 180 into, this is a non-inductive load, power factor is 1, that is equal to 41.58 kilowatts. Power supplied to the motor, root 3 into VLIL cos theta, root 3 into 400 into 200 into 0.6, 83.14 kilowatts. Total power is equal to 41.58 plus 83.14, that is equal to 124.72 kilowatts. Okay, this way you have to solve this problem. With this I conclude my lecture. Thanks for listening.